Light, shadows, and reflections. Luminous and non-luminous sources of light. A body or an object which emits light in all directions is said to be a source of light. A source can be a point source or an extended one. A point source can be obtained by placing a source of light in a box having a pinhole in one of its sides. Every source of the light available is an extended source. Some examples of sources of light are sun, fire, electric bulb, fluorescent tubes, and heated bodies. A source of light is of two kinds. Luminous. A self-luminous source is the source which possesses light of its own. Example, sun, electric arc, candle, glowworm, firefly, etc. Non-luminous. It is an object which does not possess light of its own but receives light from an external source and scatters it to the surroundings. Example, moon, page of your book, table, etc. Transparent and opaque objects. A subject through which light propagates or tends to propagate is called a medium. It is of the following three kinds. Transparent. It is a medium through which light can be propagated easily. Example, glass, water, etc. Translucent. It is a medium through which light is propagated partially. Example, paper, ground glass, etc. Opaque. It is a medium through which light cannot be propagated. Example, wood, iron, etc. Shadows. What exactly are they? A shadow is a region of absence of light. A very small source of light, called a point source, gives a sharp shadow which is equally dark all over. A shadow can be obtained only on a screen. Shadows are formed for two reasons. First, because some objects, which are said to be opaque, do not allow light to pass through them. Second, because light travels in straight lines. Shadows give us information about the shape of the object, but no information about its size. Solar and lunar eclipses are examples of formation of shadows. Umbra and penumbra. Shadows are obtained on a screen by drawing straight lines from the source of the screen touching the edges of the object kept in the path of the light rays. Shadow formation can be studied under the following two types. Shadow produced due to a point source of light, umbra. Shadow produced due to an extended source of light, umbra and penumbra. Shadow produced due to a point source of light, umbra. A point source emits light in all directions. An opaque object kept in the path of the rays blocks some of these rays, thereby restricting them to reach a screen, thereby producing a shadow. The shadow has the same shape as that of the opaque object, but is larger in size. On increasing the distance between the screen and the opaque object, it is found that the size of the shadow increases. It is found that the shadow is uniformly dark and no light reaches the dark shadow. This region of total darkness is called umbra or total shadow. Shadow produced due to an extended source of light, umbra and penumbra. For an extended source of light, the shadow consists of two parts, 1. Umbra and 2. Penumbra. The central, perfectly dark portion of the shadow is called umbra, whereas the partially dark portion of the shadow which surrounds the umbra is called penumbra. Most sources of light are not point sources, but extended over some space. Such sources are called extended sources. Such sources can be imagined as a collection of a large number of point sources, each casting its own sharp shadow. All these point source shadows combine on the screen. The darkest region is where all the shadows overlap. This is known as umbra. Surrounding the umbra is the penumbra, where only some of the individual shadows overlap. Pinhole camera. In a pinhole camera, a small hole replaces the lens. It is based on the principle that a recognizable image is formed on a screen if light is allowed to pass through a small opening or hole. Construction. A pinhole camera consists of a rectangular box made of cardboard, wood, or metal closed from all sides. On one side of the box, a screen of semi-transparent paper or grounded glass is fitted. The side opposite to this face has a small pinhole. The box is properly sealed so that no light enters it from anywhere except the pinhole. To avoid reflection of light inside the box is blackened from inside. Working. When a candle is held in front of the hole of the camera in a dark room, the small inverted and real image of the candle is seen on the screen. Narrow beams of rays from the entire candle pass through the pinhole to form an inverted image on the screen. If the camera is moved forward towards the light, decreasing the distance of the object U from the camera, the light of the image increases, but the image remains clear and focused sharp. So, there is no focusing adjustment needed. Since the image is formed on a screen, so we say the image is real. Mirrors and reflection. Many times, we would have to look at ourselves in the mirror while we are combing our hair or dressing up. Light from our face travels in a straight line to the mirror, gets reflected from it, or is thrown back from it in such a way that it comes back towards us and we see a reflected image of our face. Consider a point source of light placed at point O, distance U, in front of a plane mirror. The distance U is often referred to as the object distance. Light rays leave the source and are reflected from the mirror obeying the laws of reflection. After reflection, the rays diverge or spread out. These diverging rays appear to the viewer to come from a point I located behind the mirror. Point I is called the image of the object O. We can see the object as far behind the mirror as the object lies in front of it. A reflected image differs from a shadow in the sense that the reflected image is always of the same size and color as that of the object, whereas a shadow is always black and maybe bigger or smaller than the object.